When I was a little girl, my parents would take me to these local astronomy events in my hometown, just small gatherings with a few telescopes in a park and a handful of curious people. But to me, they felt like the biggest thing in the universe at the time. I still remember the first time I saw Jupiter and Saturn. I must have been about 8. The telescope was a small, wobbly, like 80mm refractor, not even on a tracker, and the image kept drifting out of the view. And the man running the telescope explained that we had to keep adjusting it because the Earth is moving. And that completely blew my mind as an 8-year-old. I'd read that the Earth is spinning, but seeing the planets actually slide across the eyepiece made it real. So that night I saw Jupiter's moons and Saturn's rings for the first time, and something inside of me clicked, changed. I already was super interested in planets, but now it felt like a personal connection. So from that night on, I dreamed of having a telescope of my own. It took years for that dream to come true. I didn't buy my first telescope until January 2020, after a vacation where an astronomer gave a talk under the stars, and he explained how telescopes work and how light pollution limits what we can see. And I left knowing one thing for sure: I was getting a telescope. Back home, I spent months researching and found what I thought was the perfect deal on a used scope. I was convinced I'd see everything: galaxies, nebulas, the whole universe just waiting for me out there. Then reality hit quite fast. Between the light pollution and the mount and my inexperience, I realized it probably wasn't the best choice, but that was the moment everything started. From there, I began learning, slowly, painfully, and sometimes expensively, what really matters in this hobby. Over the years, I've collected many lessons, some technical, some more philosophical, all of them learned the hard way. So here are 10 things I learned that I wish I'd known when I started. Let's get right into it. My name is Luca and you're watching The Space Koala. My first telescope was a Celestron Evolution 925, so a Schmidt-Cassegrain telescope with a 2350mm focal length. In plain English, that is a big scope with a lot of magnification for a beginner. At that time, I thought I was being smart. If I buy a large telescope now, I'll never need to upgrade. Yeah, this is not quite how it went. From my city balcony, the moon and the planets were beautiful, but deep sky objects, nowhere to be seen. That's when I discovered something that changed everything. A camera can see what the human eyes can as long as you give it time. That's how I fell into astrophotography. So for planets, that telescope was incredible. I even bought a small planetary camera and got my first close-ups of Jupiter and Saturn. But when I tried photographing nebulas, I hit a wall. They were huge, far bigger than the frame that I could get. That's when it sank in. Even if your telescope looks impressive, no single scope can do everything well. So choose your equipment based on what excites you the most. Large nebulas or small galaxies or the moon or the planets. Each design has its strengths. A small refractor is forgiving and ideal for wide targets. A long focal length Schmidt-Cassegrain, on the other hand, gives amazing planetary detail, but wide fields simply won't fit. You can do mosaics for sure, but not as a beginner. No telescope does it all. Start with what fits your sky, your patience, and what makes you look up in the first place. This ties right into the next point, the common beginner trap of thinking more magnification means better results. Most of the famous deep sky objects, the Andromeda Galaxy, the North American Nebula, the Orion region, Cassiopeia's emission clouds, are enormous. Andromeda alone spans about 6 full moons in width. Too much magnification shrinks your field of view, makes tracking errors more visible, and turns astrophotography into a frustrating fight. Bigger isn't always better. A shorter focal length captures more sky, more context, and more beauty. The magic of astrophotography doesn't come from zooming in, it comes from framing the sky right. Pair your telescope with the right sensor, think about your targets and aim for balance, not brute force. Lesson 3 came from the same mistake. My Celestron was on an alt-azimuth mount, fantastic for visual observing, but not really designed for long exposure astrophotography. At first, I didn't fully understand why or to what extent. I thought, it still tracks the sky, so it should work, right? I learned quickly. So the first problem I ran into was tracking accuracy. Even though the mount followed the target, it wasn't precise enough for the telescope's long focal length. After about 15 seconds, the stars were already starting to stretch in the trails. So I got creative. I took the telescope off completely and mounted my mirrorless camera directly on the alt-azimuth mount with a lens. It looked slightly absurd, a tiny camera sitting on that mount built for the 9.25-inch scope, but it actually worked better. So this much shorter focal length on the camera lens was far more forgiving of tracking errors, and I managed to get 30-second exposures of Andromeda that were surprisingly decent. But then another issue appeared: field rotation. Because an alt-az mount moves horizontally and vertically rather than along Earth's rotational axis, the entire field of view was slowly twisting over time. You might not notice it in an individual frame, but when you stack dozens and dozens together, you will see around the edges that it kind of starts to curve and the whole image rotates slightly. Even though the long exposures helped with the tracking, the rotation still ruined long sequences. So I understood and I accepted why everyone insisted on equatorial mounts. Once polar aligned, they track in perfect sync with the Earth's rotation, keeping your field stable no matter how long you shoot. Plus, nowadays, polar alignment is much easier than it used to be, with apps and built-in cameras guiding you step by step. So if you think you might ever want to do astrophotography, my advice is skip the alt-az route altogether. Go straight for an equatorial mount. It'll save you from endless frustration and a lot of creative workarounds that don't really work. Choosing your gear can feel overwhelming, and everyone online has an opinion. The best advice I can give is talk to people who actually do astrophotography. Manufacturer websites will always tell you their scope is the best, it's perfect for everything, but it never is. The most valuable advice comes from those who've made the same mistakes, people in local clubs or online forums who can show real results, not marketing copy. If you don't have a club nearby, the internet is full of communities like Stargazers Lounge and Cloudy Nights and Astrobin, where discussions are more grounded in experience than hype. And don't just follow one expert. Gather multiple perspectives, check their work, and form your own judgment. Take every piece of advice, including mine here, with a grain of salt. You can learn every processing trick in the book. You can buy the best tools. You can use every AI algorithm in existence, but nothing will replace clean, raw data. Under dark skies with well-tuned equipment and good seeing, you're already 80% of the way there before you even start processing. The same setup in the city, even with narrowband filters, will never be able to match that. So I've done a little bit of thinking. If I had 5 hours to shoot, should I stay home and shoot for 5 hours? Or should I take my car, drive out for 1 hour to dark skies, shoot for 3 hours, and then drive back? Every time I will choose the drive. Those 3 hours of dark sky data are worth more than 5, 7, 10 under heavy light pollution. And when your data is good, processing becomes a joy. You're not there to fix problems, you're just revealing the beauty of the data. Speaking of data quality, calibration frames do matter. Yeah, you can skip dark sometimes with modern CMOS sensors, but you can never skip flats. We've discussed this many times, but flats fix 3 things. They fix vignetting, so the natural darkening of corners. They fix dust, so those round or donut-shaped shadows from particles on your filter or on the little sensor window. And they fix PRNU, so photo response non-uniformity, which is the tiny pixel-to-pixel sensitivity differences of your sensor. And no amount of keeping your optics clean will ever fix that. Flats, however, collect all of these by teaching your processing software what perfect illumination looks like. They do require at least one bias frame or a very short dark to calibrate properly. So flats and biases are the bare minimum that you should always use. They'll save you hours and hours of post-processing pain later on. Astrophotography quietly turns you into a problem-solving machine. You start with cameras and telescopes and end up learning 3D printing, wiring, and mechanical design. You want a custom adapter or a special cable mount, you make it. You learn by necessity, and if you're like me, observing in the mountains, you eventually learn how to start a fire, not for the atmosphere, but because there's no other heat source and it's freezing. Then there's the digital side, capturing software, guiding software, stacking software, processing software, each with its own quirks and learning curves. Half your devices will eventually exist solely for astrophotography. It is chaotic, but it's also one of the best parts of the hobby because every little challenge pushes you to learn something new. At some point, we all become that person, obsessing over the weather data like our lives depended on it. Normal people check if it will rain. We check what kind of clouds there are. Are they high cirrus? Are they low stratus? And whether they're moving in or out. And we monitor wind direction and humidity and transparency and the jet streams and haze and fog and even if there's Sahara dust. And just when you think you're done, you add space weather to your watch list, aurora forecasts, solar storms, geomagnetic activity, and of course, the most spectacular aurora will always happen during the full moon. It's part of the obsession. We don't talk about good weather anymore. We talk about seeing in transparency. I remember my first images, the Pleiades with the faint nebulosity around it, the Andromeda galaxy barely visible, and how proud I was. Looking back now, they're not the best, but I love them because they mark where I started. Today, my images are objectively better. They're sharper, they're cleaner, they're better processed, yet I'm much harder on myself than before. I think that's normal. It means I've learned. My eyes have matured. I no longer settle for good enough. You should always be proud of your progress, but never expect to feel done. That constant slight dissatisfaction isn't failure, it's fuel. If you thought that you'd already mastered everything, the magic would quickly disappear. People often ask if it gets boring, photographing the same sky over and over and over. Absolutely not. If someone keeps imaging the same 2 or 3 targets, it's probably because they're beginners, starting with the brightest and most rewarding ones. But once you realize how vast the sky truly is, boredom becomes impossible. New planetary nebulas are being discovered on a daily basis. The old targets can always be reframed and processed differently or seen through a new artistic lens. That's what makes astrophotography special. It's half science, half art. You can always go sharper, cleaner, or more creative. Rotate the camera or crop differently or play with color and composition. Make something familiar look new. My own target wish list is on my phone. It's endless, grouped by month, by season, and by hemisphere. There are so many of them that I can't even see from here in Switzerland. The only real limits are free time and weather. For sure, never a lack of inspiration. I'm sure there's dozens of other things I could have mentioned, but these 10 shaped how I see astrophotography today. they reflect my experience. And while your path might differ, I suspect you may go through some of these same realizations. Let me know in the comments what your biggest lesson has been, whether it is technical or practical or philosophical. I'm glad you joined me on this little trip through some of the things that I've learned so far. Thank you very much for watching, and as always, I wish you clear skies.